Hello everyone, welcome back to ng.classes. I hope you all like my previous video, and if it helped you, please do subscribe my channel. And yes, if you want me to discuss any other topic, please comment in the comment box. So today we are going to discuss visualizing solid shapes. Here we will discuss about solid shapes, also known as three-dimensional shapes, in detail. So let's start the discussion. Now, before starting the detailed explanation about three-dimensional shapes, let's understand what's the difference between two-dimensional shapes and three-dimensional shapes. So, two-dimensional shapes, as the name suggests, any shape having two dimensions. Here, dimension means measurements. So any shape having two measurements, length and breadth, are known as two-dimensional shapes, whereas three-dimensional shapes must have three measurements: length, breadth and height. Let's see the first figure. Here we are having the first figure. It's a rectangle, and rectangle is having two measurements, length and breadth. Let's see here. Length and breadth. This breadth is also known as width of the rectangle. It doesn't have any height of its own, or we can also say two-dimensional shapes are simply a flat figure, whereas three-dimensional shape must have height of its own or depth of its own. Let's see the second figure. It's a cube, right? And this cube is having length, breadth and height, which is also known as depth. All right. Now let's see some examples of three-dimensional shape. Here we are having our first figure. It's a ball, right? And the name of this three-dimensional shape is sphere. We are having so many spherical shapes all around us. We are having a spherical shape in the form of football, or our oranges are one of the example of spherical shape, or globe also, etc. Now let's move to the second figure. Here the second figure, it's a pyramid, right? And this is also a three-dimensional shape. Let's identify the next figure. So the next figure, it's a cylindrical shape, and the name of this three-dimensional shape is cylinder. We are having so many cylindrical shapes example all around us. So we are having our gas cylinder in cylindrical shape. We are having our water bottle in the shape of cylinder, etc. Now let's move to the last one. Here the last figure looks like a birthday cap, right? Yes, it's a birthday cap, and the name of this figure is cone. This is also a three-dimensional shape, and we can also call it conical shape. So we are having so many conical shape example in the form of birthday cap, ice cream cone, or our mehendi cone. These are some of the example of conical shape. Now let's do some match the following questions. Here we are having three columns, where the first column is containing some shapes. Second column is having type of the shape, that means whether the shape is two-dimensional shape or three-dimensional shape. And the last column is containing the specific name of the shape. The first one is already done for us. Let's do from the second one. So the second figure, as we can see, it's a cone, right? And yes, it's a three-dimensional shape. So let's match it accordingly. Now let's do the next one. So the next figure, as we can see, it's a cylindrical shape. And cylinder is also a three-dimensional shape. So let's match it. Now let's do the next one. So the next figure, it's a triangle, and triangle is simply a flat figure. It's a two-dimensional shape. So let's match it accordingly. Our next figure is a cube, and cube is also a three-dimensional shape. So let's match it. Let's move to the next figure, and our next figure, it's a circle. Circle is also a flat figure. So it's a two-dimensional shape. Let's match it. Let's do the next one. So the next figure, it's a cuboid, right? And we know cuboid is also a three-dimensional shape. So let's match it. Let's do the last one. And the last figure looks like a globe, right? And we know globe is a spherical shape. The name of this three-dimensional shape is sphere. So let's match it. And hence we are done. Now we can also have composite shapes. That means combination of two or three different types of three-dimensional shapes. Let's see the first figure at first. Here the first figure, it's a tent, right? And it's a combination of a cylindrical shape and a conical shape. Can you see it? Let's see the next one. So the next figure, it's a softy ice cream. And this softy ice cream, it's a combination of a cone and a hemisphere. Now hemisphere means half of the sphere. When we will cut the sphere exactly from the middle, then we will get a hemisphere, which will look like this. Now three-dimensional shapes looks different from different angle, or we can also say that three-dimensional shapes looks different from different side. Let's see the example. So here the first example, we are having a hut. This hut, when we will look at it from the front, suppose we are standing here at the red mark, all right? And when we will look at it from the front, you will be able to just see this front view. And hence this is the front view of this hut. Now when we will look at the same hut from the side, suppose we are standing at the green mark. So when we are looking from the green mark, then we will be able to see just the green sides. And we can say this is the side view of this hut. Now suppose an airplane is going from the top of the hut. So we will be able to get only the top view of the hut. That means only this view, the top view, will be visible. Let's see the next example. So in the next example, we are having a three-dimensional shape. Here, our front view will be this is square, the green is square, another green is square, and this one, right? We will be having three squares as a front view. Now, when we will look at the same figure from the side, we will get the red square and this red square. So this is the side view of this figure. Now when we will look at the same figure from the top, we will get just the top view. We can see one top view is like this, another one is like this. And when you will look at from the airplane or from the top, this much distance will be negligible. You will feel that two floors are there or two squares are there. So that's why the top view will be two yellow squares only. And now we will discuss how to count the number of faces, edges and vertices of any three-dimensional straight face solid. So let's count the number of vertices at first of each and every shapes. As we know, vertex means corner point. So we have to count the number of corner points. So let's count it. So for the first figure, here we are having one of the corner, 1, 2, 3, 4, 5, 6, 7, and 8. So we can say the number of vertex for the first figure is 8. Alright, let's count the number of vertex for the second figure. So for the second figure, here we are having one corner point, 1, 2, 3, 4, 5, 6, 7, and 8, 9. Anything else? No. So number of corner points for the second figure we got as 9. Let's check it for the last figure. So here we are having one of the corner point, 1, 2, 3, 4, 5. Yeah. So the number of vertices is equals to 5. Now let's mark the edges of each and every figure. Now we know edges means a straight line which is connecting two faces of the figure. Or we can also say edges are a straight line which is connecting two vertices of the figure. So let's mark the edges. For the first figure, we are having this as one of the edge. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So total 12 edges are there in a cube. Let's do the same for the next figure. So here we are having 1, 2, 3, 4, 5, 6, 7, and 8, 9, 10, 11, 12, 13, 14, 15, and this one 16. So total 16 edges are there for the next one. Let's count the number of edges of a pyramid. So 1, 2, 3, 4, 5, 6, 7, and 8. Total 8 edges are there. And now let's count the number of faces of each and every figure. So for the first figure, as we know, it's a cube, and cube is formed with the help of squares. So here we can understand we are having one square in the front and one square at the back. Now we are having one square on the left and one square on the right side. Alright, so total 4 square. Now one square at the top and one square at the bottom. So 4, 5, and 6. So we can say total 6 squares or total 6 faces are used to make this cube. Alright. So number of faces is equals to 6. Now let's count the number of faces of the next figure. So for the next figure, we can start from the bottom. So at the bottom, one square is there, right? Now we are having one square on the front and one square on the back. All right. One square on the left and one square on the right. Okay. For the bottom part, we are having total 4 square all around us and one at the bottom. That means 5 squares. Now, if we will look at the front part, we can see this is a triangle. So total 4 triangles are used all along the side of the square. So 4 triangle and 5 square. That means total 9 faces are used to make this figure. Okay. So number of faces is equals to 9. Let's count the number of faces for the pyramid. So for the pyramid, at the bottom on the ground, we are having one square. Now we are having 4 triangle all along the side of the square. So 4 triangle plus 1 square. That means 5 faces are there. Now the mathematician Euler has given one formula for 3-dimensional shapes which connects the number of faces, vertices, and edges of any straight face 3-dimensional shape. So let's see the formula. Here the formula says the number of faces plus number of vertices minus number of edges will always be a special number, that is 2. Let's check it for our figures. So as per the formula, number of faces plus number of vertices minus number of edges is equals to 2. Our number of face 6, number of vertices are 8 and number of edges are 12. Here when we will do the calculation, we will get 2 only. So yes, we got the special number for our first figure. Let's check it for the second figure. So number of faces plus number of vertices minus number of edges. Let's do the calculation and we will get a special number 2 only, right? Let's check for the last figure. So number of faces plus number of vertices minus number of edges. When we will calculate it, it will always be a special number, that is 2. And yes, it is valid for the last figure as well. So this is how we will use the Euler's formula. And now let's count the number of faces, edges and vertices of few more three-dimensional shapes. So here our first figure, it's a sphere, right? And for a sphere, we can see if we will count the number of faces, we are having just one curved surface, right? If we will count the number of edges, then we can see here there is no edge. Just recall the football. Is there any edge in that? No. And how many vertices are there? There is no vertices as well. Let's count for the cone. For the cone, number of faces are 2. Here we can see a circular flat surface and a curved surface. This one is the curved surface. So 2 surfaces are there or 2 faces are there. Now what is this lateral surface? Lateral surface means the surface all around the cone. That means it's just the another name for curved surface. Number of vertices. Here we are having for a cone the corner point and there is only one corner point at the bottom. So number of vertices is equals to 1. How many edges are there? Let's see. Here we are having the base. It's having the circular base. It's one of the edge and anything else? No. So here we are having one edge as well. All right. In this figure, maybe it will look like we are having more edges, but please recall the three-dimensional shape, a birthday cap. When you will look at all around the side, it's just a curved surface or a lateral surface. There is no edge. Only we are having one of the edge at the bottom. All right. Now the last figure, it's a cylindrical shape. And here also we are having one curved surface, which is also known as lateral surface. Surface all around the cylinder. All right. So number of face, we are having one circular base at the left hand side and one circular base we are having on the right hand side. So total 2 flat surfaces there and one curved surface is there. That means total 3 faces are there. Okay. Now how many vertices are there? Is there any corner point? No, 0. How many edges are there? Let's see. So here we are having one of the edge. This is one of the edge. Here we are having the another edge. So total 2 edges are there in a cylindrical shape. Now let's discuss the concept of polyhedron and non-polyhedron. So polyhedrons are 3-dimensional shapes which is having all the faces as a straight face and which is having straight edges and vertices. Whereas non-polyhedron will not have all the faces as a straight face. We can also say polyhedrons are 3-dimensional shapes which is formed with the help of polygons. Now you must know what is polygon. So as we know, polygons are curves which is formed with the help of simple curve which has to be closed and which is formed with only line segments. Now here the first point which says simple curve. Simple curve means any curve which will not cross itself. If I have drawn this curve, here see carefully, this curve is crossing itself or intersecting itself. So this is not a simple curve. Whereas when we will draw a rectangular shape, this is a polygon because this is a simple shape. You can see it's not crossing itself, it's closed also. Closed means the starting point and end point has to be same. And this rectangle is formed with the help of line segments only. So this is one of the example of polygons. Now let's see polyhedrons. So here we are having the first example as a pyramid. Here each and every faces of the pyramid, it's a flat surface, or each and every faces are polygons. So we can say this pyramid, it's a polyhedron. Let's see the next figure. So the next figure we are having as a cylinder. And for cylinder, we know we are having one curved surface and two flat surface, the upper surface and the lower circular surface. We also know circle is not a polygon because circle is not formed with the help of line segment. So cylinder is not a polyhedron. Cylinder is a non-polyhedron. Similarly, when we will look at this shape, it's a cone, right? And cone is also having one flat surface and one curved surface or lateral surface. So, and the flat surface is a circular shape which is not a polygon. So this cone is also not a polyhedron. Similarly, when you will look at this spherical shape, it's not a polyhedron because we don't have flat surface here. So it's not a polyhedron. Now look at this figure, that is cube. So cube is formed with the help of squares, and we know squares are polygon, or cube is formed with the help of flat surfaces only. So yes, it is fulfilling the criteria of polyhedron, and hence this cube is a polyhedron. And here we will discuss few terminologies related to polyhedron. So the first one is convex polyhedron, which says when we will take any 2 points on the surface of the polyhedron, let's take 2 points on any surface and let's join them. So the line segment joining the 2 points must lie in the interior part of the polyhedron. Such polyhedron is called convex polyhedron. Let's take any 2 other points. Just join them. We can see whatever 2 points we are taking and we are joining it, each and every line segment are lying in the interior part of the polyhedron. Whereas, let's check for the next figure. If we will join this 2 point, the line joining the 2 point is not lying completely in the interior part of the polyhedron. So the next figure is not a convex polyhedron, whereas the first figure is a convex polyhedron. Now, regular polyhedron. There are 2 conditions which must be fulfilled, then only we can say the given polyhedron is a regular polyhedron. So the 2 conditions are, the first one is all faces must be a regular polygon. Now what is regular polygon? Any polygon having all sides same. Each and every side will be of same measurement. That polygon is called a regular polygon. And the second condition is same number of faces must meet at each vertex. Let's understand it with the help of example. So our first figure, it's a cube, right? Let's check the first condition. The first condition says all faces must be a regular polygon. We know cube is formed with the help of squares, And squares are regular polygon because each and every side of a square are of same measurement. So the first condition is getting fulfilled. Let's check the next one, which says same number of faces must meet at each vertex. So let's take one of the vertex A. Let's see how many faces are meeting with each other to make this vertex A. So here we can see one of the face. On the top we can see another face, and on the left hand side one more face is there. So total 3 faces are meeting with each other to make the vertex A. Now let's take any other vertex. Let's say here we are having vertex B. So to make this vertex, we can see one face is on the right, one face is on the back, and one face on the top. So here also total 3 faces are meeting with each other to make the vertex B. Now you can check by taking any vertex. Each and every vertex will be made when 3 faces will meet with each other. Hence, both the criteria is getting fulfilled for the first figure, and the given figure is a regular polyhedron. Let's check the second figure. So again, we will check the first condition, which says all faces must be a regular polygon. So here also each and every faces are of same measurement. All the triangles are same or regular. So first condition is getting fulfilled. Let's check the next one. So same number of faces must meet at each vertex. Let's take the vertex A. Let's see how many faces are meeting with each other. So we can see this is one of the face, this is another face, and there is one face at the back. 3 faces are meeting with each other to make the vertex A. Okay. Now let's check for vertex B. Now here we can see one face. Here we can see another face. Here we can see the third face, and here we can see the fourth face. So 4 faces are meeting with each other to make the vertex B. Please don't get confused. It's just a triangle. 3 triangles are on the top and 3 triangles are at the bottom. There is nothing in between. So the second condition is not getting fulfilled for the second figure. Hence we can say the second figure is not a regular polyhedron. And this was the last concept of our today's discussion. I hope you have understood the whole concept on visualizing solid shape. Stay tuned for the next video. Thank you.